you. Okay, already. So, hmm, a lot of people came earlier. So,
Dr. Jonah, good morning, good afternoon.
yeah, Dr. Francis, how are you, sir?
I'm fine by God's grace.
Yeah, good to see you
I
here.
hope you are fine too.
I'm good. Yeah, thank you.
Now, your disciples are many, so you don't seem to recognize us.
Ah, yeah, probably because you are not on camera.
Okay, so you have forgotten my face.
I need to associate your face with, to your name.
This is Francis Ghana.
Yeah, yeah, yeah. Hello, sir.
You can see my face now.
Yes, 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 yes. I can see
Okay,
your handsome face.
yeah,
Thank you,
thank you.
Dr. Francis. Yeah, I need to associate people's face to their name. That in that way,
Yeah,
I'm able to remember.
because I've been part of the first meetings, since, as the Nigerian will say.
Oh,
I've been part of the very first meeting.
very first CONGA meeting.
Yes,
Wow,
to date.
wow.
I and Asian,
Yes, yes, Asian, Patrick Asian.
Patrick Asian Ghana, yes.
Yeah, yeah,
But up to now, I've not heard much about the GNSS receivers.
yes. That's a good one, right?
Yeah.
Well, we
At the
continue
time, it
to.
sounded like within some few months, you are going to get some concrete stuff.
Yes, that was
But
our
now
hope.
it's almost more than 1 year, almost 2 years now.
Yeah. But this is really good, right? We are preparing the background work. You know,
Yeah, I'm
a lot
enjoying
of
the lectures too.
uh-huh. I'm gonna still talk about this a little bit. A lot of background work need to be done, even though we have the funding. We need that background work, which has been missing, and a lot of projects that my colleagues are, I mean, my fellow colleagues have, carried out in multiple places are not
Yeah.
really working right now. I think one of the reason is the background work is still missing. So
Okay.
Conga meeting series is actually to tackle that, irrespective of the funding or whether the funding comes today or it comes tomorrow. So that is why we are here to get to know people, to educate people, and that is why you should also invite students, professors, people that needs this knowledge more. So
Yeah.
I think we should get started because we already have our speaker, Miss Mary Dusabe, and she's from Kenya Space Agency. I think I have Yinka. Yinka is gonna be introducing her. Let me see if I have Yinka. Okay, but let's get started. And a lot of people came earlier. I think they mismatched the time that we have. The UT is 2:30 p.m., but the Eastern time, which is the US Eastern time, is 10:30 a.m. So people miss by 1 hour or 2 hours, I don't know. So next time I will try to be here maybe like 2 hours before the meeting so that I can get people to know that. Anyway, so um, today is another edition of Conga meeting that we do monthly. And as you can see on my screen here, uh, we have a little bit of outline today. And one of our outline for today is the big one is we have a guest speaker who will be talking to us about space weather monitoring. Let me see if I can put okay. Space weather monitoring uh operation at Kenya Space Agency. So Miss Mary Dusabe is from Kenya Space Agency, is an engineer there, and a little bit more about how will be uh, introduced by our own Madam Yenka Migoya. So she's going to introduce her this morning. But before we get started, I usually want to talk about the importance of this meeting and give us a little bit of updates that we have. So, um, you know, here we want people to feel free, to share. You can, when the speaker finished their thoughts, sometimes if the speaker allows, we can also interrupt at some point to ask questions, but mostly after the meeting, after the presentation, we have the time to ask questions and contribute and discuss. So that's what we'll be doing today. And also, today is the last meeting of CONGA for 2025. Yeah, we have had several meetings for this year where we invite prominent member of the community to to discuss and share their updates, the updates on their work, particularly those that are related to science and instrumentation. And we have learned a lot about this. Just yesterday, one of my former students called me and said, "Oh, this is yesterday, 2 weeks ago." So she said, "I need to access Madrigal online. I'm still having some difficulties on accessing this data. I want to have it in large numbers, uh, large downloads." So, and I was delaying in responding. So I remember that we had a presentation that has to do with Madrigal, where Engineer Bill Rideout came to give us a talk or a webinar on how Madrigal and CEDA database operates. So I just pointed her to one of the talk of that is related to that, and she was able to solve the problem. So that is why all of these meetings and discussions are very important. And also, as I will show us how it is related to Conga. So the last meeting, yes, and for 2025, and uh, next month, Miss Yenka Migoya is going to present a poster on about Conga. I think I can show us that poster quickly. Let me see if I have it opened down somewhere. So I'm not sure I have it open. But we can access the poster online on the website. Conga has a website. Dr. Francis, if you don't know, I think you are here. You said you are always here, so you know about everything that is going on here. So I'll preview this viewers websites. And if I come here, let me see. Okay, I think it's here really. No. So the poster, I put it here, become satellite poster. So she's going to be representing Conga at the meeting. This is a poster. She's going to present what Conga represents and what we are doing over the equatorial region of Africa. So that is one of the updates I want to present to us. Let me go back to my talk, and then um, you know, let me quickly see here. We have had several presenters, and I want to appreciate them, especially for this year, 2025. This is for 2025. And all of these talks are also on the website. Go back to the website again. So this website is very, it's helping us a lot to, okay. So this is the current presenter today, and those are the summary. Somebody was asking me what is the talk about today. It's already on the website. So all of the past speakers are also here. If you want to listen to any of them, you just click on view presentation here. And that is it. These are talks that are very, very educative. They are, and the purpose here is one of the purpose here is also educational. So please feel free to access these talks at your own convenience and listen to them if you wish. So I don't know if, but before I move forward, let me quickly talk about what we do. We are a network of people. We want to build a network of people that can work together, particularly over African sector, that region where we are interested. As you can see, these are the specific places that we hope to put receivers in the future, not only receivers, but ground-based instruments. They can be co-located. So this is a very, very foundation of many things to come. So when you are building a foundation, it takes time. And we need to be patient, to get it done in the right way. So if it's taking time, we understand, we're going to get there. And that is one of our objective here for this meeting. And also we want to train and develop the members of the meeting who are going to be um, associated to a particular unit of instruments in time, in later time when we actually start the deployment. All of these people that are on the meeting are going to be responsible for hosting those instruments. So you can see the importance of this meeting. Even though we don't have the funding yet, we need to establish this very basic background. It's very, very important because we don't want to fail. This is going to be a lot of instruments, 250 plus instruments and more. So we need to start the background work and show the agency that want to fund this that everything is in place. So all of this that we are doing is essential part of the main program. We also, here at CONGA, we want to also allow or ensure that there is free access to data when it comes to science. So we um, allow, we encourage distribution of data for science purposes. So we need that in our society. There are many data that are having a lot of coverage or accessibility. So in that, I believe the purpose of having instruments is to allow people to use the data for science, particularly in our own community. So if that is not achieved, then the purpose of that instrument is defeated. And that is why we at this here at Conga, we encourage very strongly that people should allow access to their instruments or data. And with that, I'm going to stop sharing my screen. I want to invite, I don't know, Yinka, is Yinka here? Yes,
Yes,
I
I'm
can
here.
see Yinka. Yeah, thank you, Yinka.
Thank you,
And
Olu.
Yinka will be introducing our speaker for today, Miss. Can you come on camera if you can?
Yes, yes. All right.
And also Miss Mary,
Coming.
can you also
Yes.
come on camera? Wow, you are hiding this beautiful face on camera. Yeah.
Thank you.
So,
Hi, Bruno.
Miss Dusabe, Are you there?
Yes.
Okay. So I'm going to leave the floor for Ms. Yinka to introduce you to the gathering. If you are comfortable, you can open your camera. Yeah, that would be fine. Thank you very much. Yeah. I don't know why people hide their beautiful face on camera.
We are
Just
shy.
imagine we are in a conference room and we just see your face anyhow anyway. That's how it is. So yeah, the floor is yours, Miss Yinka.
Okay. Do you have in a slide the Mary's bio or?
Yeah,
Okay.
I can share it. Yes.
But no, I have it. But
Okay.
if you want to
I can also
share.
share it here too.
Okay.
Mhm.
Okay, so it's my pleasure to present Ms. Mary Dusabe. Mary Dusabe is a navigation position engineer at the Kenya Space Agency, where she works with GNSS receiver networks to support positioning, navigation, and timing PNT applications. Her applied research focuses on GNSS and space weather, with recent emphasis on low-latitude ionospheric scintillation and its impact on GNSS positioning accuracy and high-frequency communications. She also contributes to routine space weather monitoring to support operational PNT and high-frequency communication services in Kenya. And today, Ms. Dusabe will present updates on some of the latest work titled Space Weather Monitoring Operations at the Kenya Space Agency. Mary, the floor is yours.
Thank you. Thank you, Bianca, and it's good to see you again.
Yeah.
My name is Mary Dusabe. I hope you can hear me.
Yes,
Yeah,
we can hear.
we can hear
Okay.
you. Yeah, if you can be a little bit better, it will be fine, but we can manage that too.
Okay. So my name is Mary Dusabe. I am a navigation and positioning engineer at the Kenya Space Agency. And today I'll be presenting about space weather monitoring operations at the Kenya Space Agency. I'll be showing some recent results or recent operations from our routine operations here at the agency. And since I will be speaking majorly about the work of the Space Weather Working Group, I'd like to say a little bit about the Kenya Space Agency. Its mandate is to promote, coordinate, and regulate space-related activities in the country. And it was established in 2017, so it's about 8 years old. And I'd just like to recognize some of my colleagues that are here. Thank you so much for joining. So I'll share my presentation. Okay. Yes, I hope you are able to see the introduction page.
Yes, that's
okay. Thank you.
Thank you.
So for my outline, I have done an introduction and I will speak about space weather instrumentation in Kenya, how they are distributed. Then I will go to data management system here at the agency. And then I will speak about how we monitor solar activity and impact assessment for systems in Kenya, and also ionospheric parameter monitoring, including the critical frequency of the F2 layer, maximum usable frequency at over 3,000 kilometers, and also the peak height of the F2 layer, amongst other ionosonde measured ionospheric parameters. And then I will do a case study, and then I will summarize my work. So this picture shows how space weather instrument is distributed in Kenya. We have several GNSS receivers are distributed as shown in this map. We have like around 6, and then this last one is a low-cost GNSS receiver that is yet to be established or yet to be installed at this location. And then we have 2 septentrion that we have available data publicly, and then the rest are low-cost GNSS receivers based on U-blocks. And then we have a magnetometer at this location and one ionosonde, which is a no-risk project, yes, in collaboration with INGV. Yes. So this is our data management system, from instrumentation, from the sensors, to how we process the data and how we get to monitor them in real time. So from the collection, we have some GNSS receivers, multiple instruments, and then various protocols are employed for data transmission. And then now the science part is this on processing. We use some Python script to extract and analyze parameters of interest, and including ionospheric conditions, solar and geomagnetic activities. And then we store in a database and we visualize. And these are our specific options for the various stages of the management system. And then we deploy using Docker for consistent deployment and also ease of portability across multiple monitoring stations. So on to our recent results, and these are monitoring activities for this week, which is 19th to 26th of October. This is a screenshot from our real-time monitoring database or dashboard, and I took the screenshot yesterday at around 05 UT. And the solar activity, generally the solar activity this week has been low to moderate, and we can see that the background X-ray flux. So this is data from GOES satellite. It is X-ray flux data from GOES satellite, and we can see that the background X-ray flux were at sea level and also predominantly at B-class flares. But we can see the largest flare for this week was M1.0 on 20th October that you can see in this red area. Then as of October 26 to 27, the sun's Earth-facing side has remained mostly quiet, and it only has some few C-class and dominantly B-class flares. This is data from the 2 days when I was making this presentation. It's just some C-class and B-class flares, so it is generally quiet or calm. From our monitoring station, we have an alert panel based on the D-region absorption prediction that alerts on the flare in progress and the expected frequency blackout frequencies. And we have 3 types of alerts. The first one states the expected HF blackout frequencies. And then if the X-ray flux conditions are low, it states that there is no significant HF blackout. And then we have configured the D-region absorption prediction to specifically to Kenya, so that when it is nighttime, it says that HF disruptions are not expected. So these are alert panels from our monitoring station. So I will go to ionospheric variability monitoring, and being that Kenya is located in the low latitude region, I've seen that maybe I mentioned a bit of the low latitude ionospheric physics so that we can appreciate the importance of monitoring ionospheric variability in Kenya and areas in the low latitude region. So this is about the plasma instabilities at the equatorial ionosphere. We know that during daytime, the zonal electric field are eastward, and when they interact with the magnetic field, they cause a plasma uplift, which is the E cross B uplift, which when the plasma by the gravity through the is pulled down along the magnetic field lines, it causes this ionization crest. So this is called the equatorial ionization anomaly. But just before, well, in the evening, the zonal electric field reverses, and it's now westward, and the plasma drifts downwards. But before this, there's an enhancement. that takes place at the equator, which is referred to the pre-reversal enhancement, which it lifts the F layer and increases the bottom side electron density gradient, as can be shown in this diagram. So because of the less density in the bottom side F layer, you can see that it can cause an instability, which is normally referred to as the relatellar instability, and it causes plasma bubbles to bubble or rise through the F layer, as it can be shown in this picture. This what formed the plasma bubbles and causes ionospheric irregularities in the low latitude equatorial regions. That is why they are prone to these irregularities. So again, this is from our monitoring. So we utilize the ionosonde, and we have where there's the ionosonde in Malindi, there's also a collocated GNSS receiver that we use for monitoring activities, and also we use a GNSS receiver that is installed here at our offices, or at our station here at Kenya Space Agency, which are the most reliable that we use for ionospheric variability monitoring. So this is again a screenshot for yesterday. How we monitor the different parameters from the ionosonde. We have the maximum usable frequency, the M factor, the height, this is the peak height of the F2 layer. We have the E layer peak height, the E layer critical frequency, the sporadic E layer height in the various panels that you can see. So what we observe, or what is generally observed in the low latitude region, is that during daytime hours, as we can see, this is from 21st to 27th. I've said I'm presenting results from this week. From 21st to 27th of October, the FOF2 values, which is this one, the FOF2 values, we see that they have remained within expected ranges between 14 to 15 megahertz during daytime hours. And we expect that the maximum usable MUF will follow the pattern of the FOF2, because they are proportionally related. They are proportional to each other. And this is the question that is connecting them. Then in the evening, as we can see in these red boxes that I have seen, we expect that this absence of FOF2 measurements due to reduction in ionospheric electron density. But what we observe here at the low latitude region, especially at the Malindi station, because Malindi station is towards the southern crest of the equatorial ionization anomaly, we see that MUF or FOF2 is still detectable at some point in the evening, in the evening time. This is we have attributed this to the pre-reversal enhancement, yes, and the equatorial ionization anomaly. Yes, we link the solar activity with the impact it has on ionosphere or ionospheric parameters. And this slide just shows some notable events this week and how it affected our systems here in Kenya. So generally this week, these were the two most active regions on the visible disk of the sun, and they produced most of the C-class flares, the ones that we have observed in the previous slide. And but this was the region, the AR4248 was the region that produced the M1.0 flare, which was the largest flare this week. And there were about 7 to 10 sunspots throughout the week. I've tried to put the image of the full disk continuum image of the active regions between 19th to 28th of October. And so there was no Earth-directed CMEs. As I said, it has been calm this week. But in as much as there was no Earth-directed CME, there was a CME from the sun's far side that produced a glancing glow. And yes, it glanced the Earth magnetic field on 27th to 28th. with fast solar wind from, so it combined the effect of the glancing glow combined with a fast solar wind from a coronal hole, although it was weak, but it was predicted. This is the prediction. This is from NOAA, from their Enlil model. It predicted an increase of the solar speed wind, and this is the actual measurement. The one that is not smooth is the actual measurement. And yes, it was a bit weak, but the solar wind for sure increased from 350 kilometer to 4 kilometer on 28th. From the is attributed to the CME that occurred on 23rd October. So here, what we did, we tried to look at the impact on our system using the ionosonde on our HF system, and this is the result. We can see this is 28th October. In the previous day, there were no echoes during the evening as expected, just like few because of pre. But for this 28th October, there was a consistent increase in F4, F2 measurement, and this could be as a result of the increase in the solar wind. Yes, this is, I've just taken this screenshot some few hours ago, and obviously this peak is going down. So this one was an overshoot. Clearly, this one was an overshoot for yesterday. Yes. So from the same monitoring station, or yes, for our operation, we monitor the total electron content and scintillation index as a result of ionospheric irregularities. And again, this is a screenshot from our monitoring dashboard in real time. This is 28. So yeah, this was taken yesterday. And for operational SO index threshold, according to ICAO requirements, the 0.3 SO index is seen as the threshold for between safe and degraded operations. And the first panel shows S4 from L1 band, and the second one from L2 band. Because it's a multi-constellation, L1 band is between 15, okay, I've not indicated here, but 15, about 1500, 1557 for GPS megahertz, and L2 is about 1200 to 1230 megahertz. The different colors show different constellations. They do Galileo, GPS, GLONASS, and the SBAS also is there. So for the L2, because of its lower frequency, it is expected that it has higher, it is affected more. So from this, we can see that the amplitude scintillation index for the L2 band is higher, and severally has passed the 0.3 threshold. So the 0.3 threshold is the one shown by the red line. And so the current observation are moderate scintillation levels, weak to moderate scintillation levels, and just in few instances that the S4 values have crossed the 0.3 threshold. And what this means is that positioning various papers have shown that scintillation greater than 0.3 can cause vertical positioning errors exceeding 4 meters. So, and this means that it can cause degradation, because for ICAO, they require vertical positioning accuracy of less than 4 meters at 95% probability. So this is why it is important to provide real-time advisories aligned with the 0.3, 0.5, and 0.8 thresholds. This one you can see here, 0.3 for degraded, noticeable degradation, 0.8 for significant disruption, and above that for service outage possibility. So this one just outlines an anomaly that was seen with the GLONASS constellation. Yes. So for the TEC and S4 measurements, again, this is from our real-time monitoring dashboard. So for the current observation this week, or between October 26th to 28th, the peak VTEC values were 70 to 80 tech units. This, I should mention, this is from Malindi station. I will show the current conditions from KSS station, and we can notice the difference. In nighttime, it's minimum as expected, and then we can observe the pre-reversal enhancement here, as it's a typical equatorial behavior. Yes, and for what this means for operationally, especially for single frequency receivers, single frequency users, is that let's say for the 80 TEQ, using this formula for ionospheric delay, for the 80 TEQ, that means there's 13 meters delay, and for L2, it is a 21.4 meters delay for the same measurement. So L2 experiences 65% more delay than L1 due to lower frequency. So single frequency users are mostly affected, but they rely on ionospheric models. Yeah, that like Klobuchar that corrects like 50%. But for dual frequency correction, it is made possible by the ionospheric linear combination method that is outlined here. It cancels first order ionospheric effects, which are 99%. So it is reliable. So I'm going to show a case study of a recent storm that I have picked. There have not been any recent significant storm since. And this is a case for 1st June 2025. And there was a G4 magnetic storm. And the storm originated from this active region that I've shown here. And it released an M8.2 flare on 30th to 31st May 2025, which was, yes, it was an Earth-directed tsunami, and this was the speed that it traveled with. Then it was a multi-CME event, possibly from the same region. The initial phase, the sudden storm commencement, I can show here the sudden storm commencement was around 0542 UT. And yes, we can see a quick transition to the maximum DST. And the main phase peaked with a KP index of 8 and DST of -152 on 1st June at 10:07. The main phase was 10:07 UTC, and the recovery phase was not as smooth. We can see multiple substorm signatures towards the recovery phase. Some of the substorm passed the KP6 threshold. So what this means for Kenya and how we analyzed it for the real-time measurements. This presents measurements from our Malindi station and our KSS station for this case study of 1st June 2025. And we can see that for Malindi, what I mentioned earlier, that the most noticeable difference between Malindi station and Nairobi station is how the Malindi station has higher tech values than the KSS station, which possibly is because the Malindi station is towards the southern crest, more than the Nairobi station. For the effect of the storm, we notice a positive storm during the positive ionospheric storm during the main phase of the geomagnetic storm. The Nairobi station of the KSS station shows a double peak, which is also a double peak. We can see also like probably peaked from the substorm of during the main phase of the storm, but Malindi station does not show this. The Malindi station peaked up to 82 TEQ. So I think I did mention that the red line is the median quiet VTEC, and the blue line is the observed VTEC. Yes, and so that we can see the difference. So the difference was about 30 to 60% increase on the from the deviation from the quiet conditions. And during the recovery phase, we can see that the positive storm persisted on 2nd June. Especially, it showed more on the TSS station. Then this is attributed to the daytime eastward prompt penetration electric field that the prompt penetration electric field is known to cause an increase or expansion in the equatorial ionization anomaly. So this causes an increase in plasma, or it causes an enhancement in plasma density during the storm's main phase. And then during the recovery phase, yes, I've mentioned that there was a positive effect that was recorded. And again, I think we can all notice this increase, especially in KSA station. It is important to mention that this was due to another storm that was underway by the time the CME that caused this 1st June 2025 storm was being released. We can see it here. This storm here is what caused this effect that is more pronounced at the Nairobi station than at Malindi station. Yes, I think. Yes, so yes, I've said that it was the May 29th to 30th. It was a G3 level storm that was still ongoing by the time the M8.2 flare erupted from the region that I mentioned. Okay, that's it. So for now, for the ionospheric irregularities measurements, we monitored ROTI, the rate of change of the TEC index, and it shows the ionospheric irregularities, and which are interesting during geomagnetic storms. So for during the main phase of the storm, we see an inhibition of again the red line shows 30-day median ROTI, and the blue line is the measured ROTI, or rather the calculated ROTI. So with a decrease in this 1st June, which was the main phase of the storm, there is a decrease which can be seen more in the Nairobi station. The Malindi station shows a decrease, but not so much. There was still some irregularities. We can see that generally irregularities are higher in this Malindi station than Nairobi station. For this time, the irregularities remained relatively higher at Malindi station than at Nairobi station. So the suppression in ionospheric irregularities during the main phase of the storm, and also during the recovery phase of the storm, was attributed to several reasons. One is because of the timing of the storm. The timing of the storm was at the timing of the main phase of the storm was around 10 UT, so that is 13 local time in Kenya. That is during the noontime, or afternoon time. And so that is way before the pre-reversal enhancement that is required for formation of the ionospheric irregularities. Meaning by sunset, because of the upward plasma drift, there's less plasma available in the bottom side F layer. So there is no steep density gradient that is required for the relatellar instability that causes the ionospheric irregularities. So this was one of the possible reasons that caused the suppressed ionospheric irregularities later on the main phase of the storm. And during the recovery phase, it is because of the DDF, the disturbance dynamo electric field, that is a mechanism during the recovery phase of a storm. So the DDF mechanism weakens the local sunset pre, And of course, that one inhibits ionospheric irregularities. These observations are in line with Aaron's hypothesis, which mainly focuses on how the timing of the storm is related to the inhibition or the generation of ionospheric irregularities. So irregularities remain relatively high at Malindi during the beginning of the main phase. Yes. So this is again an impact assessment of now when we use ionosonde data, and this is for F0, F2 measurements, which are directly proportional to the maximum usable frequency. And we have used the 27-day median F0, F2 to compare with the observable measured F0, F2 to be able to analyze the deviation of the F0, F2 from quiet time conditions. This is the main phase of the storm. And we can see, due to the positive storm, we can see an increase in the F0, F2 values, which follows the increase in the plasma density. The increase in the plasma density because of the positive ionospheric storm that I have mentioned. And during the recovery phase, or even in the evening of the main phase, we can see a decrease in F0, F2 because of the disturbance enamel effect. And during the recovery phase, there's a slight decrease in F0, F2. So for my summary and conclusion, yes, we have used a limited sensor network to try and get specific information, especially over Kenya, which is region specific. We have existing data pipeline, which demonstrates that demonstrates operational readiness for expansion. Scientific significance, the Kenya's location in equatorial region bridges critical knowledge gaps in low latitude atmospheric physics, or in low latitude atmospheric regions which are prone to irregularities, and which is an underrepresented region, especially in the our specific longitude in global monitoring. So we have also demonstrated operational impact, and according to the case study of October 23-27, and also the case study, the just concluded case study of June, the first June geomagnetic storm. It shows how GNSS degradation from scintillation and HF disruption from solar flares, and how this causes effects in our technological system in Kenya. So we have noted that comprehensive monitoring is required. It is not sufficient to depend on the GNSS receivers, few GNSS receivers, and also one ionosonde, just to be more reliable. So that is a gap on infrastructure as well. So according to our documented observation, for the frequency and also the intensity of disturbances, it is seen that, like for the scintillation, it's seen that it is not just a rare event, it is persistent. The irregularities are persistent, and this just underscores the urgent need for network expansion. And then ionospheric irregularities are, yes, I mentioned that they are persistent, and this one puts to risk the regional dependency on GNSS-based services that makes forecasting center essential. So for our path forward, we are looking forward to expand the instrumentation network. That one is really core, and we can do this through strengthening international collaboration to initiatives like this, which we look forward to, collaboration and building technical capacity. And we are looking forward to transition from monitoring to forecasting. On this, we are validating models like the IRI over our region and trying to assimilate the real-time data just to have a region-specific result. Yes, that is the end of my presentation. Thank you so much.
Wow, thank you, Miss Mary. This is wonderful. Thank you very much. I always like space agency um, analysis or um, existence, the reason why they exist in the first place. As you can see, how the Kenya Space Agency has also showed us almost real life or real time analysis there and comparing the space weather activities through um, solar activities, geomagnetic storms with ground-based data like ionosonde and GNSS TEC. So this is really a wonderful presentation, Miss Mary. Thank you so much for the effort you put in this presentation. I see that you have result of yesterday in this presentation, which is extremely uh, wonderful and shows your commitment to this presentation. We really thank you very much. And also, we thank the Kenya Space Agency for allowing you to participate in our meeting this morning. And I see a lot of improvements. I know Dr. Rabiu, Professor Rabiu will chip in on that as well. So I just want to appreciate the Kenya Space Agency for this opportunity to allow us to see what they are doing in that end of the world. And this is also a challenge to other part of Africa that may want to establish this kind of agency. So with that, I'm going to open the floor for questions. I think I see Professor Rabiu's hand. Please take the floor, Professor Rabiu.
Okay, thank you very much for bringing us together again. Our CONGA man.
And, Professor.
So I want to really appreciate the work presented by Mary. I've dropped a message in the chat box, but I still need to comment publicly that that's a good one, and I'm happy with the courage with which you carry the KSA and the work that is going on, and we wish to see it, to see the work grown to a level that we want to see it. So that's a good one, Mary. I will just make a comment on the work, which you have the case studies and other things you mentioned. Now, there is a model that we need to project, not just because we're Africans, but because the model has been proven to be very effective, and that is the Afritech model. And the Afritech model is doing well. You have it for the quiet time, you have it for the storm time, and it's being developed by the Africans that work together with our collaborators as well. So when you see the papers that carry the Afritech, the papers on Afritech is not only done by Africans, but is a model that specifically focused on Africa. And that paper, the work, the generic algorithms and other things have also been used to develop models in some other regions outside Africa. And the model is quite effective. The work I will be presenting and my partners will be presenting at the Beacon Satellite Symposium compare the fluctuations during storms and that of Afritech. Observations and Afritech model. So don't just use even the South African regional warning. The regional warning center that is located in South Africa is using Afritech as part of as one of the models. They are using it in the prediction that they are doing. So please, Mary, you link up with the team or you check the papers. The model is freely available. You can download it just the way you download IRI as well. But that does not mean that we should stop using IRI. It's very effective. So we'll work on this together. So I think I will stop there. The other response, I've made that response. So Bruno's question on the chat box, Malindi Station and Nairobi, the stations have different topography. They have different geographical coordinates. And Malindi is closer to the ocean. And then there are all these the differences, all these different positions will mean different responses of the ionosphere to whatever is happening, whether during the quiet time or during the disturbed times. So this may be object of research for some other persons, but surely the ionosphere varies over even a very short distances. So, and this is what we appreciate in the presentation that is made here. Thank you very much.
Yeah, just to that, Miss Mary, probably you might want to put the geomagnetic coordinates instead of the name of the station or both, because that will help us to analyze very quickly what is happening between the different geographic region. So, like, the magnetic coordinate is more important and it helps us to analyze plasma variability across low latitude and equatorial region. And that is what I will just add to the title of or the caption of the results from those two stations, because they show different kind of result and people will be very curious to understand the difference between the geomagnetic geomagnetic coordinates there. And also I'm coming to Bruno. So Bruno, be ready. I think I'll give you the floor instead of testing. You can also chip in quickly. So on slide 14, I was like, what? I see that irregularity that you showed comes up before the storm time, and they are very prominent irregularities that you show through the ROTI. What is going on there? Do you want to show us quickly?
Yeah, I want to show you. You're
Yeah,
saying,
this one.
which one?
Yeah, that on the one on the left, and because you show the geomagnetic storm starts on the third or fourth day, and look at the irregularity very strong before
This
those days,
one.
and then during the geomagnetic activity and during the recovery phase, you see suppression of those irregularities compared to the main activities.
Yeah, so the suppression, maybe the suppression can be understood because of the effect of the storm. But for these few days before the storm, the irregularities are seen to be much, much higher than even the median values.
Yes.
Which I'm not sure what it is, honestly. I think it's something that, I tried to check if it's a result of the storm that happened here, but again, I realized that it continued.
Yeah,
and
it's
maybe
a very strong irregularities that could have resulted from geomagnetic storm activities or something. Yeah, that is very interesting to actually investigate.
Yeah.
Well, I think, sorry, I have to just chip in. There has been papers. There have been papers on the irregularities over the ionosphere, over Kenya and some other low latitude region. I think even in the PhD thesis of Owendo, who has also made presentation on this platform, there have been a lot of work on the irregularities, and that is why the African equatorial region has been presented as the regions where we have more irregularities, occurrence of irregularities more than other regions within the equatorial region. And the degree of irregularity in East Africa is also of concern when you compare it to that of the West Africa as well. So this is not new per se, but it's also good that we continue to take statistics to study this and to get more results. So Mary, you can find more explanations if you just pick any of the papers of Owendo. You will see some good explanations that have been given there. Thank you very much.
Thank you,
Prof.
Prof. Yeah, so uh, looking at this result, Miss Mary, I feel that the geomagnetic storm activity is actually suppressing the irregularities before it. You see, you have 3 days before the activity, and then on the activity day, it started going down and it continues to go down. So I think this is a very important aspect to study. Though Professor said this has been in the literature, so let's see. Maybe in the next meeting, if you
Yeah.
having time to come to this next meeting, we would like to find out what is going on here.
Okay. I think so. This you see the geomagnetic storm is here in this green dashed line. So the occurrences forward can be explained by the effect of the the storm, but this one, especially for Malindi station, because for Nairobi we cannot see that. We see the ionospheric irregularities are in line with the median region.
Exactly. Yeah.
So it's an issue of the Malindi, and I think, as Prof has said, I will investigate that.
Right. So the other station behaves the way you expect it to behave. That's what I expect actually.
Yeah.
That jump in irregularity around the day of the storm. And before the storm day, you see lesser irregularities. But the other station is not, is the opposite, exact opposite. So
Yeah,
yeah, let's see. I think you put an eye on that.
I will. I will for sure.
Yeah. So Mr. Bruno, sorry, I'm going to come to you, Mr. Joseph. So can you ask a question, please?
Thank you, our Congo man. I want to thank Professor Robia said. Thank you, Mary, for the presentation. Just a few questions on my side. I think on slide 10, you had a presentation on the scintillations. Yes, that one. I just wanted to know on the dashboard, does the dashboard scintillation index that you're showing, does it show for each station, or it gives the calculations for all the stations, then it gives you an average of what we are seeing here, this screenshot that you're seeing in the slide?
So it shows for each station. Oh, sorry.
For each station.
Yes.
Okay. Then my next question comes from a recent paper that I read about geomagnetic storms and PPP, precise point positioning. And they have an argument in that paper where they say that ionosphere free linear combination will always work when the ionosphere is not disturbed. So I really want to know, especially this slide that you have projected, that during the storm time, when you apply that combination, do you still get the same 13 and the 21.4, or things change? It is something that triggered that's the origin of my question. Besides that, thank you very much. I think I'm still interested in knowing slide 13. If you can show us the receiver which is at Malindi and the receiver in Nairobi, are they geodetic receivers? Are they the same? Then have you tried to look at the signal to noise ratio for each receiver, just to be sure that the receivers are within range? So whatever prediction of tech that they are doing can't be doubted or questioned. Besides what Professor Rabi has pointed out, Thank you very much. Good work.
Welcome. So I'll start with the one for the difference in values for Malindi and Nairobi. For the geomagnetic latitude, Nairobi is around 11 and Malindi is around 15, so that's not much. But what Professor Rabiu has said about the topography, the geographic location is something that I need to find out. So yes, about the ionosphere free linear combination. This calculation is based on the observed tech already, but I tend to think that according to the formula, if there are disturbed conditions, then it might probably also reflect on the pseudo range measurement. So I have not researched on that, but there's a possibility that the argument could be true. But the traditional argument is that the ionosphere free linear combination works because it's just a matter of the difference between the F1 and the F2 frequency.
Right.
Yes.
Okay, so I will move. We have two more hands raised, so we are going to take those two questions because we are running out of time. We will not be able to take more questions than these two hands. Or if you have any other question, you can type it in the chat box, and Miss Mary will reach out to you later. Mr. Joseph, am I right with Mr. Joseph or Dr. Joseph?
It's Mr. Joseph. Thank you, Doc. I hope you can hear me.
Yes, please.
Okay, mine was just a comment regarding the comment you made on the irregularities. So one observation that we make is that they happen post-sunset hours, and they are more pronounced with the receivers near the equatorial anomaly crest. And it's not just with the ROTI. The scintillation is also seen with S4 index, and also during the post-sunset hours, there is a pronounced vertical total electron content. So it tends to rise. And then also, I just wish to take this opportunity to congratulate my colleague for the wonderful presentation. Thank you.
Thank you.
Oh, yeah, I remember Mr. Joseph now. Yeah. Thank you, Mr. Joseph, for coming on the program. Yeah, I remember I contacted you, or you contacted me about this presentation in the first place. So thank you. Miss Mary, do you want to answer that question, or is that just a comment?
No, it was a comment
Oh,
because
okay.
we have worked together. Yes, I
Yeah.
believe so, Mr. Joseph. Yes.
Okay. So, any other question, Mr. or Dr. Ojo? Do you want to ask your question? Hello? So, why I think Ojo Boss is not ready to ask his question right now, and I will just ask my final question. How many? This is just curiosity. Like, how many receivers do you have in Kenya?
Okay. We have three septentrial, but we have access to two, the data, and the rest are low cost and recently installed, and we are also trying to have their data in the system.
Okay, so how many do you think you will need more? Because the mission of CONGA is to have this GNSS receiver and other ground-based data distributed across Africa. So since we have you on ground and you are representing the Kenya Space Agency, we can have an approximate idea of how many receivers or GNSS receivers the whole of Kenya will need in order for you to do your job in a more effective way or show us more statistics and things like that. What is the approximate? You may not have just a rough answer, could be okay.
Yeah, I had actually not thought about this.
Yeah, okay. That's fine.
Well,
Yeah, but
if
yes.
I for Mary, we can bring as many as possible, 100, 100,000, we can accommodate.
Yeah.
And then we also need to be careful, because that's the comment I was putting in the chat box, because Bruno mentioned that the specifications of the the receiver in Malindi and Kenya Space Agency, I may not remember the specifications. I know I've seen that of Malindi, but I don't know if it's a septentrion, no, or it's another make. So we need to, so if we're bringing CONGA GNSS to a location, the specification will be uniform. And then we don't need to recalibrate our preliminary results to others when we want to do comparisons. So I will want to say that we don't shortchange Kenya when we are distributing CONGA. If we want to give 100 to Kenya, we should bring 100. We should take 100 to Kenya. So I speak on behalf of Kenya Space Agency. Thank you very much.
Okay, Prof. Yeah. Yeah, I'm just curious. I wanted to use Kenya to gauge other country how much how many receivers they will also need. But we are getting there. Finally, I think I see a hands up. I don't want to ignore that hand. So quickly, Mr. Valencia, you could ask a question.
Yeah. Thank you, Bruno, and thank you, Professor Abiyu, and thank you, Mary, for the presentation. Mine is just a supplement to your question on the number of receivers. Automatically, what Professor Abiyu has said is the best. One, you cannot populate the receivers in only one location, because remember, the IPP coverage also matters. Otherwise, you will find that if you place a station here, another one next to the other, then automatically the TEC computation that they will be giving will almost be the same. So at the end, if you want to study any feature, then you will almost be studying the same feature. So as you populate the receivers, you also look at the IPP coverage and the distance of one receiver to the other. Otherwise, thank you, Mary, for a wonderful presentation. Thank you, Bruno, and thank you very much.
Yeah, thank you for that, Mr. Valencia. This is really good contributions. And let me just share my screen to finally close off this meeting. Sorry, I think let's see. Okay. So Miss Mary is our last presenter for this edition of 2025 CONGA, and we really appreciate her and the space agency. This is I think we will go to other space agency in Africa in our next edition, 2026 edition. And I think Professor Rabi will help us to actually coordinate that because he is a very vast person in this business. So I think I'll be reaching out to other space agency. This is wonderful. And I like or I love the way you actually projected the space weather with regards to all the parameters within days, like a day before, right? I know if I give you time, you show us today. And that shows how much the Kenyan Space Agency are actually in this business. So we thank you very much and thank you for showing very, very good example. So in November and December, we are not going to have this meeting. I've said that earlier, but we are going to be having CONGA represented particularly by Ms. Yenka at the BBC, that is Beacon Satellite Symposium in Rome, I think. So she's going to be presenting perspectives of on CONGA. So that is really, really good news for us. And in December, I will be attending AGU. I'm also going to present. We'll have a session actually, and I'm going to be presenting some stuff on CONGA as well, just to get it out there. And very soon we will start seeing response, and we will start having this instrument by God's grace in places that they need to be, hopefully. So keep your finger crossed and pray for CONGA. Let's for the success of CONGA. So uh, January is, I mean, 2026 is around the corner, and we are having multiple suggestions of people that can come. One of them is Jorginho. Dr. Jorginho is a new scientist, early career scientist. He has been working very hard on developing model for TEC, and he has now joined the University of Massachusetts Lowell, and it's very close by to my side here. I'm talking to him, and we will bring him on this channel. He's going to tell us a lot of beautiful things that he has been doing in um, incorporating different data into uh, his model, and how that is different from other models. So it's really, really wonderful work that he has been doing, and he got hired by the University of Mass Lowell recently. And we also have Danny Scapion. He's a senior research scientist, and he's the director of Ikamaka is still gonna be talking to us maybe in February. I'm going to make sure I get that closed by December when I'm at the AGU. So we'll have him come and talk to us about Ikamaka data. So if you are interested in data analysis, how data from radar can help your analysis, you can attend and bring your friends and your students to also attend. Frank is one of my students that recently finished his doctorate, and he's also interested in giving talk on this stuff. So that is a brief introduction, I mean, a brief comment on what we're going to have next 2026, and many more will come, and we will see that in January, hopefully in January or February, when we will start the new edition of CONGA. So with that, if there is no other questions, I think we have overspent our time. Normally, we take like 10 to 15 minutes outside the 1 hour that we promise. Yeah, that is what we do, because when we have discussions on the platform like this, I always want to allow it to flow. So thank you
A
all.
quick one, please.
Yes, please.
Please, I've seen the CONGA website, and I want to humbly request that maybe you have maybe an option for people to register as members of CONGA so that you know your disciples.
Yeah, we have to register for CONGA to be a member.
Like maybe on the website, so you can have
A
I
review.
know previously, yeah, I filled some forms, but I don't know how formalized it was. Previously, we were asked to, give locations where you'll be citing. Like ACN was doing that, was coordinating that in Ghana, and
Oh yeah, yeah.
my institution was registered. I don't know if you remember.
Yes. I
So I don't know if it would be possible to have some feature on the website where possible, partners of
yes,
CONGA, maybe in the various countries can be registered.
yes. That's really, really good suggestions. And I will try to incorporate that on the website. That is really, really good. So that will help us in the distribution of this instrument. You see, this is why this meeting is very important, because we get to discuss the way we can make ground-based instrumentation work in Africa. And this is just a starting point. This is just a starting.
Okay.
Thank you,
Okay,
Dr.
thank you.
Thank you so much. And with that, there is no other questions, right? and we will call it a day from here. Thank you again, Miss Mary, and nice meeting you. Yeah. Thank you, everybody.
Thank you.
Thank you,
Thank you, too.
everybody.
Thank Prof.
Thank you, Asante
Thank you,
Sana.
Sas.
Karibu.
Bye.
Bye, Professor.
Mm.
Bye.